All right, welcome to yet another scalable challenge lab for AZ900. In this one, we're going to take a look at scalability of virtual machines using Azure scale sets. All right. So we are here in our pre-configured lab environment, and we're going to start off by creating a scale set. So the easiest way to do that, in my opinion, is to look for scale sets. And you can see virtual machine scale sets. And then we create one. As with everything, we need to have a resource group for this one. So we should have a pre-existing one, and we do. We have a name for it, virtual machine front end. East US is okay with us. Security type, we're happy with just standard security. The scaling mode currently should be manual, and the instance count should be 2. We're happy with that. We want to use a 2019 data center image, and then we want the instance to be a B2S instance. We need to go and look for that. There it is. The administrator username should be student, and then we have a really cool password. We're not interested in spot, but for disks, we're going to change the disk type to an HDD just for cost considerations. For networking, we want a new network to be created. Let's just change the name of that. We're otherwise happy with the network itself. Data allowed 490.422.60 VNet. All right. Then for load balancing options, we want an Azure load balancer to be created. And then we need to give a name for that load balancer as well. It's going to be VM front end load balancer. All right, let's try to create this. All right, and the scale set has been created. So let's go to it. And then here under availability and scale and scaling, we can set some parameters. So what we want to do here is do a custom autoscaling. We want to scale based on a metric. And then we need to add a rule. And we're interested in the metric being percentage CPU. If it is greater than 80, let's say, let's just change something here. Then increase count by 1, and then the cooldown is 5 minutes. This should work. Then we should add another rule for scaling down. So again, if percentage CPU is less than, and let's say 25, then decrease count by 1. Okay. So 2 very simple rules. If the average CPU of our instances is over 80, we're going to add an instance, and then if our average CPU of our instances below 25, we're going to remove 1. We're going to set up the minimum amount of instances to be 2, so that we're always highly available, and then the maximum number of instances to be something like 4, just to make sure that we're not, using up too much money in case there is some kind of a misconfiguration. So saving that. So that should be okay now. Another way to create a scale set would be using a template. So let's go and take a look at the GitHub repo. So here we have a repo that has a scale set of Linux VMs behind a load balancer. We can take a look at the actual ORM template here. Here are the parameters. Here are the resources. Virtual network, subnet, storage account, network interfaces, public IP addresses, and then virtual machines as well. All right. So this would be one option, to use a pre-existing template. This one, we can just deploy to Azure using this handy link here. So this will go to our deploy custom template functionality in Azure, and then automatically pull the template from the GitHub repo, as we can see. We just need to select the resource group here, and then we're happy with East US. The VM is supposed to be standard A1 v2, that's okay. With Ubuntu, we want to have 1604 LTS, that's okay. The name should be VM followed by the project number. And we want to have 2 instances, and the admin username should be student. And then we want to use a password type of authentication, and then the password is going to be this one. All right, let's see if this works. All right, that's created. So let's go and take a look at our scale sets. So now we can see we have 2. The one that we want to go for now is the newer one, the VM one we just created. And then here we can take a look at scaling. And for our purposes, let's do again autoscaling here. And then scale based on a metric and a rule. Let's use percentage CPU again. If it's greater than 80, increase amount by 1. That's okay. And then the scale in rule. If the percentage is less than 25, then decrease count by 1. Minimum 2, maximum 4. Could work again for us. And then let's save this. Okay, so let's take a look at our other scale set. So this is the one that we created manually. And let's find the public IP address for it. This one. And then let's add a network security group. We can do that over here via networking and then network settings. And then what we can do here is create a rule. What we want to have is an inbound port rule. And we want to allow from any to any ports 3389 and 80 and 443. And basically we want to allow RDP, HTTP, and HTTPS. I don't know why those T's were small. All right, that's created now. So now we should be able to connect to the instances. And let's do that via the load balancer. Okay, so let's find our load balancers. Use the front end one. This was the one that we created ourselves. And here we have front end IP somewhere. It's here. Cool. We need some inbound NAT rules. And there should be a NAT rule for the 50,000 early range to NAT to 3389. So that works for us. That basically means that now what we can do, this is actually okay for us. What we can do here is we can actually run an RDP client, MSTSC, yeah. And then we can connect to the IP address of the load balancer. Cool. And then you just need to change the port to be, in that range. So 50,000 will be the first one that will work. And now it will connect us to one of the backend instances, right? So the username here was student. And then we had a good password as well. And that works. So I'm just going to kill the session, just showing you that it actually worked to connect to the backend. And with that, we got to the end of our lab. I hope you enjoyed it. I hope you learned something new, and see you in the next one. Till then.